Hey guys, it's me Alif. Let's learn about the projectile motions. Okay, we have learned about the kinematic equation to describe the motion that moving horizontally, okay, like a car, as well as the object that moving vertically, like a ball falling straight down to the ground. Okay, what about the object that move of these both directions? This type of motion, if it involves the object that is thrown or launched into the air, it will refer as a projectile motion. Okay, imagine a cannonball being fired at some angle from a horizontal. It will travel some distance up into the air before falling and hit the ground. Okay, and we can use a parabola to represent the path of this object. The important thing to understand from this example is that the vertical motion and a horizontal motion of a cannonball are independent of one another. This means that we can use a separate equation that discuss the motion in each direction. Okay, one of the equation that is exclusively correspond to the x coordinate, and another that is exclusively correspond to the y coordinate of the object.
Hello everyone, so today our group is going to do two different experiments using. The first experiment is we're going to use three different types of ball. The first ball is the volleyball. The second ball is the futsal ball. And the third ball is the basketball. That's for the first experiment. We're going to use three different balls but using one initial angle. Our second experiment is we're going to only use one type of ball but different initial angles.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Amir Kimuzini. So I would like to discuss about experiment 1, which is the same angle 45 degrees. So our projectile move at a constant speed in the horizontal direction, but what makes the difference is the gravity force that pull the object to the ground in the vertical direction. So the heavier the ball, the stronger the pull of gravity. Then it make the heavier ball fall faster and it shorter the time and the distance is short. So in this experiment, the force applied to the weight ratio is the same. Therefore, we can say that the heavier ball is rather small. Hence, why the trajectory is shorter in both distance and time.
Okay. Assalamualaikum warahmatullahi wabarakatuh. My name is Hakim Fakri. We'll tell about the experiment 2. So in experiment 2, we use one type of ball, which is volleyball, but different initial launch of angle. So the variety of the distance obtained is because of the different initial angle. So which is the longer distance of between this angle. So the one closest to the 45-degree angle, we have a longer horizontal distance. This is because the 45 degrees is called optimal projection angle. So a launch at 45 degree angle of degree will have a better balance of initial velocity component that optimize the horizontal velocity and time in the air. The projection velocity of the ball remain almost constant across all projection angles.
So moving on to the next, which is the calculation. So by conducting the previous experiment, we obtained several information, which is the angle, the time taken, and the initial velocity. So to solve this calculation, we need to find the final velocity. So there are several equations that we need to apply to get the final velocity. So for the calculation, we need to find the final velocity. So from the previous experiment that we conducted, we get the angle is 45 degree and the time taken is 2.97 seconds and the initial velocity is 7 meter per second. So firstly, we need to determine the velocity in the x-axis. We assume that the rightward movement is the positive. So by inserting all the information in this equation of motion of the x-axis to find the answer, we'll need to insert 7 meter per second and then cos 45 degree, and we'll get the answer is 4.95 meter per second. We can say that the movement is positive, which is the movement of the ball is toward the right. So next is we need to determine the velocity in the y-axis. So you can see here is the acceleration. Noted that acceleration here is equal to negative gravity because gravity is acting toward downward, that's why there is a negative sign here. So it will equal to negative 9.81 meter per second. So by inserting 7 meter per second and then plus negative 9.81, then times the time taken, which is 2.97, we will get the answer is negative 24.19 meter per second, which is the movement of the ball or the element is toward downward because the sign negative here. So to find the final velocity, we need to apply the last equation, which is this one, by inserting previous answer, which is 4.95 square plus negative 2419 square. We will get the final velocity, which is 24.7 meter per second, and that's the final velocity of the ball before it hits the ground.
Hello, my name is Isahir Mahmud. I'm going to talk about the conclusion. As per the conclusion, we are using the equation of projectile equation of motion. In this experiment, we are allowed to determine the range of projectile. By using the kinematic equation, we use the exact same initial velocity, the same height, by neglecting air resistance and by using the exact same force. From the result of the first experiment, we can say that mass really affect the range of projectile. From the equation of motion, F equals to ma, we can say that higher mass, heavier mass will make the projectile even shorter. On the other hand, as for the second experiment, we can say that 45 degree is a very optimum and very ideal angle to use the projectile. This is because the angle above 45 degree and even below 45 degree is only lowers the effectiveness of projectile itself. So we can say that those angles that were above 45 degree and even below 40 degree only lowers the distance of projectile. Thank you.